Move on our agenda. So we go to the second presentation of this panel. It will be hosted by my dear colleague, Steve Dawson. I had the privilege to know Steve for some years now. Dr. Steve Dawson, he holds a Bachelor on Engineering degree from the McGill University and Master of Applied Science and Doctor of Philosophy degree from the Department of Metallurgical Engineering at the University of Toronto. Steve joined the Swedish startup company SinterCast back in '91 as technical director and was appointed president and CEO 11 years later in 2002. During this time, SinterCast has grown a lot to support the production of more than 1 million cylinder blocks per year, which is amazing. And its Foundry licenses have grown to include 55 foundries in 14 countries. SinterCast is naturally a public traded company on the stock exchange, and the value market is approximately $150 million. So Steve is also chairman of the International Standard Organization, Standards for CGI, and is also author of several chapters for CGI in the IFS Iron Casting Engineering Handbook and in ICM Metals Handbook. That's very good, and makes me a little bit jealous because I was never invited to write anything for the ICM Metals Handbook, and I will like to have the opportunity. So maybe for the future. So Steve will give us his view on the future of powertrain, where are cars and trucks going, is a high expert on the subject, and for sure the presentation will be of high value for our Congress. So Steve, you have the word.
Yeah, thank you, Vitor, and good morning to everyone. And I can say that you're most welcome to write the next chapter. You can enjoy those weekends. I'm past that stage, I believe. It's certainly an ambitious topic to predict the future, but let's have a try. We're all friends together here. Last week, I participated virtually in a powertrain symposium in Germany. There were papers there about engines and electrification. There were papers about different fuels and fuel cells. And what I noticed was that all of the presenters were convinced that their path was the best path and that their path would prevail. And of course, they can't all be right. Today in the industry, there are a lot of ideas, there are a lot of opinions, but there's also a lot of uncertainty. And I think what I'd like to do, similarly to what Paolo did, is to go back a little bit and start with what we know. I won't go back quite as far as he did, but if we look at the last few years, Vitor showed similar data in his presentation from ACEA, the European Automobile Manufacturers Association. And we can see over the last 4.5 years, I'll just take the pointer. Yes, certainly petrol engines and diesel engines have decreased, but they still make up about 2/3 of the total volume. We see that hybrids in gray are increasing, but this is all types of hybrids. So it means mild hybrids like 48 volt, where we just drive ancillaries such as power steering and air conditioning off of the battery instead of taking parasitic losses from the engine efficiency. And battery vehicles are still less than 10%. Of course it will grow, but what it means today is that more than 90% of the vehicles sold in the European Union are sold with an internal combustion engine. Yeah, and that is our starting point. We can do the same thing for passenger vehicles in North America. And here it's almost funny. What we see is 90% petrol, and this is quite stable and long-standing. In the next overhead, we have changed the axis on the left so that we can see the development of alternative powered vehicles in more detail. And what we see again is that in gray, the hybrids are growing, but still less than 5%. And in fact, diesel has also grown in recent years as these pickup trucks and heavy SUVs have brought on diesel engine options to try to help meet corporate average fuel economy goals. And we see that battery electric penetration still below 2 or 3%. Yeah. With that as a base, we can look forward and we can project how it might develop. And this is a recent plot. It's just 5 or 6 months old now from Deloitte and IHS. And what they show is the projected growth in plug-in electric vehicles. So it means both BEV and plug-in hybrid vehicles, and growing in the different regions of the world with a global average. And we see out in 2030 that somewhere around 30% perhaps. And again, it's very difficult to predict the future. Since this plot was published, some governments have come out with bold targets for electric vehicle penetration in 2030. Some OEMs have likewise come out with bold predictions. But I think in the end that the pace of the rollout of electrification will be a function of legislation, infrastructure readiness. And I think about the presentation of Paulo, which I agree with most of what he said, much of what he said. But to bring electrification into the cities, we really need to develop the infrastructure. And that will also go to consumer acceptance. Not everybody in the city has a driveway where they can park their own vehicle and charge inconveniently overnight. It will also depend on cost. Much of the cost is offset by government subsidies. We have to see how that develops. We spoke about cost parity for electric vehicles coming in 2020, and then it was pushed out to 2023, and now generally it's pushed out to 2027. So it is a moving target, and it is an important part of the puzzle. And likewise, range. So we have the driving range and the range anxiety, and we speak about parity with internal combustion engines. And the target for that in the industry now generally is that around 2030, there may become range parity. And I think if we summarize and we say, where are the cars going? Broadly speaking, the cars are going toward electrification. And let's see the pace of that. I think that out in 2030, it'll still be well more than 50% of the vehicles having an internal combustion engine, either for primary drive or as a range extender. I think that what we need to do in this transition is just to make sure that we're sensible. And Paulo spoke very well in response to the question from Ralph Marquardt about a holistic approach and doing something that has a net benefit. At the moment, we still see some silly things, and this is a very complex problem. And there's a wonderful quote from the American journalist Mencken from the 1930s, who said, "For every complex problem, there is a solution that is clear, simple, and also wrong." And I think that we as a society have to avoid that. I just want to leave this section as we move from cars and we scale up toward the trucks, with a couple of photos where there are inconsistencies. There are things that are silly. And here we see a European electric charging station on the side of a motorway. And behind the charging station, we see a diesel generator. So every day, a diesel truck drives to this station, fills it with diesel fuel, and when somebody needs to recharge at the roadside, the diesel generator kicks in, generates electricity, and refills the batteries. And this is a nonsense. It's a stepping stone until the infrastructure is developed, but still, for us, it's an obvious nonsense. And we see it also. This is a roadside service vehicle. which has an internal combustion engine, which is towing a trailer that has a portable diesel generator, and the diesel generator is being used to recharge an electric vehicle. So I think that while we have our enthusiasm toward electrification, we also need a sensibility. And let me move now from cars toward trucks and pickup trucks and medium duty, and then on to heavy duty trucks. Let's ask, where are the trucks going? We can start with light vehicles that Vitor mentioned, and also with full-size pickup trucks. Generally speaking, these vehicles use the same powertrains as passenger cars, and therefore they will follow the same path as passenger cars. For these last mile delivery vehicles, and these are business vehicles, the decision will be based primarily on total cost of ownership. These vehicles, full-size pickups in North America, and the pace will be driven primarily by consumer acceptance. And in this
So we had a small problem with Steve's presentation, so he's not on the online with us anymore. So we might have had some small issue with his network connection. So I apologize for that. We will give Steve a few minutes to rejoin the Congress. So while we wait for Steve to join, I will take the opportunity to apologize to Fernando Machado, as he had a question that he wanted to make to Paulo, and he did not have a chance to do it, and this was on my side, the mistake that I had. So Fernando, if you are with us online, I think you are.
Sorry, Vitor, can you hear me now?
Yeah, I can hear you, Steve.
I'm so sorry, the connection dropped.
No problem. We can resume. So Fernando, sorry, I will go to your question at the end of Steve's presentation. Sorry for that.
So I will.
Thank you, but I think it's not necessary.
Okay. Thank you, Fernando. So Steve, we are back with you. So you are back online. You were cut on the moment that you were talking that light commercial vehicles, they are driven by total business cost.
Yeah. So the light commercial, as I say, both of these vehicles generally use passenger vehicle engines. The light commercial vehicles are commercial vehicles, and therefore the decision will be based primarily on total cost of ownership. The full-size pickups, which are popular in North America, these are personal vehicles. They'll be driven primarily by consumer acceptance. We saw in the previous plot from Deloitte and IHS that America is lagging Europe in the forecasted uptake of electric vehicles. And again, that's because of the size of the vehicle and the consumer acceptance, which in turn lagged in China, which is driven primarily by legislation rather than consumer acceptance. And if we step one higher in the vehicle class, we now come to the Super Duty pickups, which are popular in North America. Ford, General Motors, and Ram, Stellantis all have Super Duty vehicle options. These are driven primarily by 6.7-liter diesel engines, and this is the domain of diesel. both for the duty cycle of the vehicle and for the behavior and the mindset of the owners. And I see that the Super Duty vehicle class will maintain internal combustion engine, maintain primarily diesel engines, well beyond 2030. Let's continue to step up, and now we'll look at medium-duty commercial vehicles. And just a few months ago, in June of this year, Scania published a life cycle assessment of a mid-size commercial vehicle. So this is for urban delivery. It's the type of vehicle that goes back to the depot every night and can have an opportunity for recharging. It's a very good and very comprehensive study that's available on the Scania website. They compared a 300 kilowatt hour battery electric vehicle to a 9-liter diesel engine. They established 500,000 kilometers as the lifetime for the life cycle calculation. They didn't include recycling. They did include vehicle recovery. And they didn't include any provision for battery replacement during the lifetime. The payload was reduced by about 1 ton to 6.1 ton. And as it shows, the gross vehicle weight was increased by 1 ton because of the higher mass of the batteries. So let's look at the result of the life cycle calculation. It's presented in the way that we're all familiar with, where we break down the CO2 equivalents as a function of the production phase, maintenance, the use phase, where we have well to wheels, and then the tank to wheel, and finally the recovery phase. And what Scania calculated was that based on 2017 European grid, the life cycle CO2 for the battery electric vehicle was 38% lower. And again, I think this comes to the question that we had in the previous paper about that the batteries and the electricity generation also create CO2. But what we see over and over again in the life cycle analyses is that the use phase dominates. And therefore, it is common that in passenger vehicle and light commercial vehicle, that the battery electric vehicle has a lower life cycle CO2. The study then went on to suggest what would happen as the grid became cleaner. I'll just take the pointer again. As the grid became cleaner, moving from 2017 to 2020 on to 2030, and if the energy could be entirely from renewables, and in this example, they used wind rather than hydro, and you see that there's a continuous decrease and a larger and larger advantage for the battery electric vehicle. And I accept these results. In the paper, Scania also included an analysis of HVO. So this is recycled cooking oils and greases and diesel fuel coming from plants. And that also provided a 74% reduction in lifetime CO2 based on an 81% reduction in the well-to-wheel energy CO2 emissions. And I think it is a pity that they didn't include the HVO bar in this diagram. I think it would have been a more comprehensive and a more honest portrayal of the results. But as I say, they did include it. They have either zero impact or near net zero CO2 emissions. And I think that we have to leave the fuels open as one path for the future. There is a lot of information now in the public, and Vitor, I think you did a very good job of showing different news clippings to support where the media and the sentiment is heading. I'm doing the same here. This is a Scania press release from just about a year ago, where they say that they will invest over 1 billion Swedish crowns, so 100 million euros, in a new battery assembly plant at their main manufacturing facility in Sweden. So yes, the OEMs also on the commercial vehicle side are making investments in battery plants. Here's a press release from earlier this year from Volvo saying that they are ready to electrify a large part of their goods transport. What Volvo said in this press release, and you can see it in the text, is that 45% of all goods transported in Europe today are transported less than 300 kilometers. And Volvo says that their batteries have a range of 300 kilometers, and therefore their vehicles could be used to transport approximately half of all goods in Europe, or that half of their vehicle sales could be electrified. I guess that math is okay, but I don't think that it addresses the problem properly. People don't buy vehicles because they can do 50% of the journeys. To the contrary, people do not buy vehicles because they can't do 50% of the journeys. And I think that philosophy applies up to the 80 and 90% percentile. You know, how can we as business people and workers buy things that can only do 80 or 90% of our tasks? Most businesses run on a profit margin of less than 10%. And so if you buy tools that can only do 90% of the work, it's a very difficult proposition for your business. So I think it is a positioning in a positive way, a green positioning of the company. But I don't think that the one-to-one math is the correct perspective. I don't think that companies are greenwashing themselves. I think that they are presenting themselves as progressive. They're aligning themselves with what investors and governments want to hear. And that's fair enough. But again, we have to be balanced and sensible in it. And these press releases help us to move from medium duty to heavy duty. And while both Scania and Volvo are making positive presentations about electrification, they're also investing in new foundries for heavy duty combustion engines. So this is a press release from Scania from 2017, where they are investing 1.5 billion in a new foundry. And that foundry is opening just now, just in the next weeks. Volvo also announced that they are investing 1.6 billion Swedish crowns in a new, well, not in a new foundry, but in foundry upgrade of their foundry in Sweden. And that foundry upgrade will be ready in 2023. And these are long-term investments that will pay back over, more than 10 years. And it shows that the companies have a long-term horizon and a long-term expectation for the production of internal combustion engines. Let's look then at heavy duty in much the same way that we looked at passenger vehicles. So this is actual data for current sales in Europe and North America. And we see here that for heavy duty, diesel clearly dominates. There are some small reference productions of other types of vehicles. And the thing now that we have to evaluate is how will these other technologies evolve over the next 10 years and the next 20 years? And let's look at those one by one. So first for natural gas. Natural gas gets a lot of attention. I'm not entirely convinced about natural gas yet. Yes, it has a 10 to 20% CO2 reduction, and that's a good contribution. But how will the governments approach it? Will the governments invest billions, either billions of euros in Europe or billions of dollars in North America to develop the distribution infrastructure when what they really want is to move away from fossil fuels? What is the logic of making that big investment in something that they hope to phase out that's only short term? Diesel particulate filters have also evolved very positively over the last years. And we see that natural gas vehicles emit 5 to 50 times more ultrafine particulates than diesels. And of course, it is the particulates that are the health concern. You know, CO2 goes toward global warming, NOx and particulate go toward health. We also have to be cognizant that methane, which is the dominant constituent of natural gas, is 82.5 times more harmful than CO2 for global warming in a 20-year perspective, and 30 times more harmful than CO2 in a 100-year perspective. And so what's really interesting, I take this example of a study done by ICCT. It was published just last month. It was commissioned by the California Air Resources Board, CARB, and I've just cut and pasted the conclusion, but they have advocated to CARB that diesel is a better alternative in the immediate term than natural gas. And again, the three reasons: infrastructure investment, the overall health impacts, and if we consider the methane escape, what they call fugitive losses, either in the production phase, in the transport phase, in the vehicle fueling, or in the vehicle use phase, only a small amount of methane escape totally negates the benefits in CO2 reduction. So it is getting a lot of attention. It will grow. It does have good contributions, but I'm not at all convinced that it is the solution or the best way forward. Let us look at hybrids, and we'll work our way through each one of them. So in fact, with hybrids, again, there is a limited CO2 reduction for heavy-duty vehicles, something on the order of 10%, but there's a high on-cost. It isn't attractive from an owner proposition for total cost of ownership. Battery electric vehicles, well, there's a real question now about weight versus payload. In the Scania example of the urban distribution medium-duty vehicle, it added 1 ton to the gross vehicle weight. But for a heavy-duty commercial vehicle, long-haul vehicle, generally the vehicle weighs about 15 tons, and the payload is also about 15 tons. At the same time, the vehicle will carry somewhere between 750 and 1,000 liters of diesel fuel. And to get the equivalent of 1,000 liters of diesel fuel today in batteries, considering energy density, it requires 10 tons of batteries. So we sacrifice 70% of the payload. So at the moment, there are some demonstrators and some examples, but generally, I don't think that the industry sees battery electrification as the way forward for heavy duty. And there's a concern about driving range. When we recharge, the vehicle is stationary. Vehicles don't make money when they're stationary. And the cost is still 2 to 3 times higher than the internal combustion engine. And something that we don't really have in the media, a consideration that isn't made, is that we don't have the battery production capacity to do cars and trucks. And generally, the initial capacity for battery production will go to passenger vehicles. Yeah, so I see a very long-term future for the heavy-duty diesel engine. Synthetic fuels, I think it is really interesting, and whether we speak of HVO or we speak of the so-called C1 fuels, where there's no carbon-to-carbon bond, so we have less CO2 and less particulate on combustion, and things like OME that are drop-in fuels for diesel application. I think really interesting, but what we need for them to be competitive in the market is a change in legislation. We have to move from tailpipe, which means tank to wheels, to a full well to wheels assessment. And either that or government subsidies in order to make these fuels really competitive. I think they're really interesting. My fear is that they're lagging and that they'll have a difficulty to catch up. But overall, in terms of infrastructure and CO2 reduction capability, I think it's probably the best bet. I don't think it will prevail, but I think it's probably the best path. And then we come to fuel cells. Well, fuel cells are very interesting. There's a question about the development lead time and the vehicle cost. Surely it's nothing for this decade, but it's a very interesting technology for the longer term future. and they are fueled by hydrogen. And this brings a real question. If there's going to be a hydrogen infrastructure, how shall we use it? Shall we use it in fuel cells, or shall we use it in an engine that looks like the current diesel internal combustion engine? You know, there's a lot of benefits to that. We always, in the old days, we used to talk about recycle. And more recently, we talk about reuse and then recycle. And if we take that approach, the reuse, we can reuse all of the manufacturing infrastructure, whether it is the foundry, the machining, or the engine assembly. We can reuse the service network. We have the familiarity of the owners and the operators. And we don't need rare materials like lithium and cobalt and rare earths. And we also have the total cost of ownership question. So I think there is a real opportunity for hydrogen to be used in internal combustion engines in the longer term. And we see that that's starting to move. So just in the last days, Cummins has made an announcement that they will hydrogen development for the 6.7 liter B engine. It's the highest volume mid-range engine in the world. So it's a wonderful test mule for Cummins. They've also announced that they will develop a hydrogen internal combustion for their 15 liter engine, which is their workhorse for North American long-haul transportation. TU in Germany is developing hydrogen internal combustion engines. They have actually been funded by the European Union, and the European Union has become an investor in the latest round of investment for TU. Also, in the last couple of months, we had an announcement from Westport, TUPY, and AVL to develop a heavy-duty internal combustion engine based on hydrogen, which has the same thermal efficiency, meaning something reaching or approaching 50% thermal efficiency for heavy-duty hydrogen-fueled engines. And in the bottom corner, we see that JCB is already launching demonstrator vehicles for hydrogen internal combustion engine. I said earlier that I think we have to have a balanced approach. And this is a lovely quote from the president of Cummins. She says that Cummins continues to be committed to help our customers decarbonize and to successfully navigate this journey to zero emissions. They've announced an environmental sustainability plan and set specific goals for 2030, as well as some goals for 2050. And here she says, our view is that in order to reach the goal in the way that is best for both the environment and our customers, it requires a continuous focus on advancing these zero carbon capable technology, on the advancement of diesel and internal combustion engine in parallel with advancing these zero carbon capable technologies like fuel cells and batteries. We need everything. There isn't a one size fits all solution. Yeah, we need a really holistic approach to this complex problem. So in summary, where will we go? Passenger vehicles, plug-in electrification will continue to grow. Let us see what the pace will be. The OEMs are generally supporting it, but starting to give cautious messages to the legislators. Here in Europe, the president of ACEA, who is also the president of BMW, has really made a good appeal to the European legislation that we need the infrastructure to come in parallel. We can't just do this by legislation. You may have seen that the president of Toyota has been very outspoken on the future path. In Japan now, 70% of electricity is generated by fossil fuels. And he has famously said, the more electric vehicles we make, the more CO2 we make. He advocates that hybrid is a better solution than battery electric vehicles. And just last week, he said that if everything changes to electric in 2030, Japan will lose 5.5 million jobs in the manufacturing sector. So again, we need a really holistic approach. I believe that well more than 50% of passenger cars will have internal combustion engines in 2030. And as Vitor said, it is all related to the 2050 net zero commitment. And stepping up to super duties, considering the duty cycle and the driver profile, And this continues to be the domain for internal combustion engines, and particularly for diesel. I see that prevailing well into the 2030s and beyond. And finally, for commercial vehicles, the diesel dominates. Diesel will continue to dominate well beyond 2030. There is legislation that requires demonstrator vehicles to be sold by all OEMs in 2025. That can be electric because the technology is available. It may also be fuel cell, and particularly for depot vehicles. And those niche demonstrator vehicles will get more media attention than the remaining 98% of the market. And for us on the manufacturing side, we just have to accept that. And fortunately for us, we get paid in cash, not in newspaper ink. So our businesses will continue. Fleet depot applications in particular will continue to grow, where the vehicles can come back to the depot every night for recharging. But for long haul, heavy duty, there is no alternative to diesel on the horizon. And there's going to be a lot of development of all of those different technologies. I don't think that the path will be known until sometime between 2030 and 2035. And I don't think that the path will change very much before 2035. So with that, Vitor, I say thank you again for the invitation, and I'm happy to discuss.
Thank you so much, Steve, for your presentation. Very interesting, with a lot of data, but very well structured, like always. So I have 2 questions to make you, but I will give the word first to our audience. I'm looking here at our chat, and we have here a comment and a question from Ralph Marquardt. So it starts by saying, Steve, congratulations to your great presentation. I fully agree to your opinion that long-haul trucks will not become, I will not come to battery electrification. So I see a big chance to come to synthetic fuels for such trucks. We could use the existing infrastructure. This is not a contradiction to your opinion that hydrogen will become an important element for the future. Hydrogen will be also used to produce synthetic fuels. Internal combustion engine has no bad footprint. It is the fossil fuels which have the bad footprint. So this is the opinion that Ralph wanted to share with you.
And I agree fully. And as I said in the presentation, I personally think that the best path is synthetic fuels or zero carbon fuels. I just worry that they are lagging the other technologies and that they're a little bit late to market. We see that a lot of the people who are advocating different fuels have different blends and different proprietary ideas, and they're competing against each other. And I'm not sure that that is helpful. But yes, I believe that holistically, the best thing for the industry, the best thing for the environment is to use the existing infrastructure, to reuse the existing infrastructure with low carbon fuels.
Yeah, and in the technology point of view for internal combustion engines, what changes if we go from diesel into synthetic fuels or to hydrogen, or the combustion of hydrogen?
Yeah, good question. We speak about drop-in fuels. So a lot of these fuels like HVO and like OME, these are drop-ins. So nothing changes. You just roll up, whether it's a car or a truck, you fill the tank, and totally zero change. That's the intent of the term drop-in. On the hydrogen side, that's an open discussion. How will the hydrogen be used? Will we use a spark to ignite it, like in a spark ignition engine? Some of the development is using a pilot injection of diesel. So you also have a diesel tank, and as you inject the hydrogen and the air, a very small amount of diesel fuel to start the combustion. But of course, then you have some carbon and NOx emissions from that. Very small, very small. It's near net zero, as the industry says, but still it's not zero. And the third way is to try to develop hydrogen as a compression ignition with a high peak firing pressure, as we do today in diesel, and which would also give us the highest thermal efficiency, approaching 50%. And I think those three paths will develop over this decade, and we don't yet know which will prevail, either spark ignition, pilot ignition, or compression ignition. But again, I think we're looking at the development decade. I don't think trucks change before 2035.
Yeah. So they have still all these options. They still have a long way to go in the technology side to be robust, to be applied in the day-to-day use.
And please let us not make the decision before the data are available.
Yeah. So one question again from the audience. So José Rego from R&D department of the APICO Foundry. So is asking, knowing that OEMs have lost a significant amount of their credibility in the last years due to the Dieselgate, who is in fact in the driver's seat on how do we avoid to follow political sound bites in definition of future technologies for the automotive industry. So who is in charge now of the strategy?
Yeah, good question. Not the industry. I would say probably the media. The media convinces the man on the street. The man on the street votes for the government, so the government follows his opinion. I think the circle is backwards at the moment.
Yeah, so we see a lot of political decisions on technology that does not come from the industry that is developing it.
Absolutely not, and we have subsidies, and we had a question to Paolo earlier about the revenue from parking, but there's also the revenue from fuel. Right, and this is a really big problem in North America. We use the fuel taxes to pay for the road infrastructure and the repair of the roads and the bridges. And when we don't have that, what is the revenue model? It's a really big question. I think I come back to the quote of Mencken. It's a complex problem, and I'm not convinced yet that we are treating it as such.
Okay. One last question, and this will be from my part, Steve. Knowing the foundry industry as well as you know, how is your view on the impact of this shift, especially on passenger cars from internal combustion engines to electric, and the long use of internal combustion engines in trucks? How is this affecting or will continue to affect foundries, or especially cast iron foundries, in the following years, and what options you think they have?
Yeah, foundries have to diversify. I mean, if you are a foundry serving only passenger vehicles, that's a tough. If you're an iron foundry supplying only passenger vehicles, that's a tough path. Aluminum is growing, electrification is growing. If you do commercial vehicles, I think that you have a much better future. I'll put a plug for SinterCast. Moving from gray iron to compacted graphite iron is a real growth opportunity. You said earlier that we make more than 1 million engines per year. That's true. We talk in engine equivalents, which is just our metric saying that every engine weighs 50 kilograms. So in engine equivalents, we're operating just over 3 million currently, and that will go to 5 million within our 5-year planning horizon. We see double-digit growth throughout the next 5 years, and we'll grow beyond 5 million to 7 million. So for SinterCast, focusing on compacted graphite iron, I see a really strong growth throughout the decade, and I see a stable plateau throughout the 2030s. So I think that the foundries have to pick their segments and specialize.
Perfect, Steve. Well, I will not take more of your time. thank you so much for your time. Thank you so much for your share of knowledge here with the attendees and your vision. And I hope I can find you or meet you soon enough. If it has to be a weekend to write something for the ISM handbook, then be it. But you are more than welcome to come here to Portugal, and I hope we can see it in the near future.
Well, and Paulo has convinced me to visit Lisbon, so I'll see you.
Yeah, we can also do that. Yeah, for sure. Thank you so much, Steve.
Dear friends.
Thank you. So then we will move on in our agenda for the last presentation of this morning. So we